Morning, students. Today we're going to discuss about the forced response. Time response analysis of discrete time signals already we discussed in the last class. So forced response is also started in the last class. So we'll see again. Okay. What is meant by forced response? The forced response of the system is obtained by summing the particular solution and homogeneous solution. So particular solution and homogeneous solution, that is yp of n and yh of n, and finding the coefficients, the homogeneous solution, coefficients of the homogeneous solution, so that the combined response yh of n plus yp of n satisfies the zero initial conditions. Okay, this is the forced response. Here we are summing the particular solution and homogeneous solution and finding the quotients of the homogeneous solution, so that the combined response will satisfy the zero initial conditions. Here we'll substitute the values of 0, 1, 2, like that, depending upon the difference equation. Okay, so a general form of particular solution for several types of inputs is as shown like this. So this is the input signal. Yp of n is the particular solution. Okay, so delta of n, that is impulse function, its a particular solution is 0. Step input a, its particular solution is k. A into m power n, that is k into m power n. Okay, a into n power m, that is k naught into n power m plus k1 into n power m minus 1 plus k2 into n power m minus 2 plus dash 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 up to k into m. Similarly, a power n into n power m, that is a power n taking as common k naught into n power m plus k1 into n power m minus 1 plus dash 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 kn. Similarly, cos omega n sin omega n, a cos omega n, a sin omega n, then c1 into cos omega n plus c2 into sin omega n. Here a, capital M, capital N, and C1 and C2, these are all constants. So these are all the particular solutions for the given input signals. These are all some of the input signals, right? Some of the inputs, and for these input signals, the particular solution is like this. Okay, right? So you see some problems. So find the forced response of the system described by the difference equation, which is given as y of n plus 2 into y of n minus 1 plus y of n minus 2 is equal to x of n plus x of n minus 1 for a given input. Here the input is signal should be necessary given, that is x of n is equal to 1 by 2 whole power n into u of n, 1 by 2 whole power n into u of n. Okay, so what is the given difference equation? That is y of n plus 2 into y of n minus 1 plus y of n minus 2 is equal to x of n plus x of n minus 1. Here we have to write this in the forced response. Forced response is nothing but a combination of particular solution plus particular solution, here particular solution plus homogeneous solution, that is yn of n yh of n plus yp of n. First of all, we have to write the forced equation as a combination of particular and homogeneous solution, that is yf of n, y forced response of n is equal to yh of n plus yp of n. What is the yh of n? Homogeneous solution for this one, yh of n is equal to c1 plus c2 into minus 1 whole power n. That is the solution for homogeneous equation, right? What is the given input? X of n equal to 1 by 2 whole power n into u of n. So write the particular solution for this given input, that is yp of n equal to k into 1 by 2 whole power n into u of n. Okay, k into 1 by 2 whole power n into like this, k into 1 by 2 whole power n into u of n, right? Right. So then yf of n is equal to c1 plus c2 into minus 1 whole power n plus k into 1 by 2 whole power n into u of n. Right. So our difference equation can be written like this: k into y of n is k into 1 by 2 whole power n. Okay. Plus 2 into y of n minus 1. That is 2 into k into 1 by 2 whole power n minus 1. Why? Because here the input is given as 1 by 2 whole power n. That's why here we are writing 1 by 2 whole power n, right? Plus k into 1 by 2 whole power n minus 2 is equal to 1 by 2 into x of n, that is 1 by 2 into whole power n plus 1 by 2 into whole power n minus 1 whole into u of n, right? Here maximum n minus 2 level is there, so n minus 2 which is equal to 0 or n is equal to 2. Substitute n equal to 2 in this equation. So k into 1 by 2 whole power 2 plus 2 into k into 1 by 2 whole power 2 minus 1, that is 1, plus k is equal to 1 by 2 whole power 2 minus 2, that is 0. Okay, 0. 1 by 2 whole power 2 plus 1 by 2 whole power 2 minus 1, that is 1. Okay, so k into 1 by 4 like this, so we will get the value of k as 1 by 3. Okay, so what is the particular solution? Yp of n equal to k into 1 by 2 whole power n into u of n. Already calculated the value of k is 1 by 3, that is 1 by 3 into 1 by 2 whole power n into u of n, right? So after that, first of all we have to add these two solutions, and finding the quotients of the particular particular solution, and apply the initial conditions. Okay, so in order to determine the values of c1 and c2 by applying the initial conditions, so yf of n equal to c1 plus c2 into whole power minus 1 whole power n plus k into 1 by 2 whole power n into u of n. Okay, so 0 here. So yf of 0, that is c1 plus c2 into 0, that is 0. C1 into minus 1 whole power 0, that is 1. Plus k into k is 1 by 2, 1 by 2 whole power 1 into u of n. Okay, 1. So it is equal to y of 0 is c1 plus 1 by 3. Okay, substitute 1. So we will get y1 of n equal to minus c1 minus c2 plus 1 by 6. Substitute in the equation also. We substitute the values of 0, 1 and 2. So y of 0, so that we will get y of 0 equal to 1, or c1 plus 1 by 3 equal to 1, and c1 is 2 by 3. Similarly, by substituting 1, we will get y of 1 equal to minus 1 by 2, or minus c1 minus c2 plus 1 by 6 is minus 1 by 2, and c2 is 0. Like this, by substituting these values, finally we'll write the solution for the forced response, that is y of n is equal to 2 by 3 plus 1 by 3 into 1 by 2 whole power n into u of n. 2 by 3. 2 by 3 is nothing but uh, c1 plus c2 into minus 1 whole power n. Okay, that is the solution. Okay, we are writing this particular particular force response solution as combination of the particular solution and homogeneous solution, and finding the quotients of the homogeneous solution. Okay, after that we will apply the initial condition, 0 initial condition. So finally we will get the force response as yf of n is equal to uh, 2 by 3 plus 1 by 3 into 1 by 2 whole power n into u of n. Okay, so in the same manner only the another problem, that is find the forced response of the system described by the difference equation y of n minus 4 into y of n minus 1 plus 4 into y of n minus 2 is equal to x of n minus x of n minus 1, with the input is x of n equal to minus 1 whole power n into u of n. Okay, so what is the given difference equation? Y of n minus 4 into y of n minus 1 plus 4 into y of n minus 2 is equal to x of n minus x of n minus 1. So what is the force response solution? So y of n is equal to yh of n plus yp of n. So yh of n is c1 plus c2 into m um, into 2 whole power n, 2 whole power n. So yp of n is what is the input given? Minus 1 whole power n into u of n, that is k into minus 1 whole power n into u of n. So by adding these two, so that we will get yf of n equals c1 plus c2 n into 2 power n plus k into minus 1 whole power n into u of n. Okay, So this is the difference equation can be written in terms of the input signal. So minus 1 whole power n minus 4 into k into minus 1 whole power n minus 1 plus 4 into k into minus 1 whole power n minus 2 is equal to minus 1 whole power n minus of minus 1 whole power n minus 1. Maximum is n minus 2, which is equal to 0. N is to substitute the value of n equal to 2 in this equation. We will get the value of k is 2 by 9. So yp of n is equal to 2 by 9 into minus 1 whole power n into u of n, right? So after that we will find out the coefficients c1 and c2. So okay, so by substituting the values of n at 0 and 1, so that will get y of 0 equal to c1 plus 2 by 9, y of 1 equal to this one. So after that, in the equation of zero initial conditions, in difference equation we will apply the zero initial conditions, so that we will get y of 0 equal to 1, then c1 equal to 7 by 9, then y of 1 equal to 2, then c2 equal to 1 by 3. By substituting the c1 plus c2 into n into 2 power n plus 2 by 9 into minus 1 whole power u of n, right? So this is the solution for the forced response yf of n, forced response, right? See, this is about the forced response. Next, coming to the frequency response analysis of discrete time systems. So far we discussed about the time response analysis of discrete time systems, forced response, and then frequency response analysis of the discrete time systems. So the output y of n of any linear time invariant system, an input signal x of n, can be obtained by using the convolution sum, that is y of n is equal to sigma k equal to minus infinity to infinity h of k into x of n minus k, or x of k into h of n minus k, right? Where h of n is the impulse response of the system. Okay, so let us consider a complex exponential signal, that is x of n equal to e power j omega n as input to the system. Then the output is given by y of n equal to sigma k equal to minus infinity into h of k into, here x of n is given as e power j omega n, but x of n minus k can be written as e power j omega n minus k. Okay, e power j omega n minus k. So sigma k equal to minus infinity infinity h of k into, we will expand this e power j omega n into e power minus j omega k, right? So y of n equal to, extract the e power j omega n at the outside. So sigma k equal minus infinity into h of k into e power minus j omega k. This is nothing but a Fourier transform. Fourier transform of h of k, that is h into h of e power j omega, e power j omega n into h of e power j omega, where h of e power j omega is equal to sigma k equal to minus infinity infinity h of k into e power minus j omega k. Here the quantity h of e power j omega is called the frequency response of the system. So this is called the frequency response of the system. Okay, h of e power j omega, which is equal to sigma k equal to minus infinity infinity h of k into e power minus j omega k, which is called the frequency response of the system. So the frequency response is a complex valued function. It can be expressed in polar form. So for our simplicity, we can express this. It is in complex form there. So for our simplification, we will express this in polar form as h into h of e power j omega as mod h of e power j omega into e power j omega theta. So where h of mod h of e power j omega is called the magnitude response, and it is an even function of omega, that is mod h of e power j omega is equal to, even function means it's a reflection, mirror image is equal to the original image. So mod h of e power minus j omega, and theta omega is called the phase response of the system, phase angle of the system, and it is an odd function of omega, that is theta omega is equal to minus of theta of minus omega. Okay, so this is about the frequency response of the frequency response analysis of the discrete time systems. So for analyzing the frequency response analysis of discrete time systems, we'll write the uh, output of y of n as a convolution sum of the impulse response and the input signal, that is sigma k equal to minus infinity to infinity h of k into x of n minus k, right? Sir, here we are taking the input signal x of k, x of n as complex exponential signal, that is e power j omega n. So replace x of n minus k as e power j omega n minus k. Okay, so sigma k equal minus infinity infinity h of k into e power j omega n into e power minus j omega k. So that is y of n is by extracting e power j omega n outside. Sigma k equal to minus infinity infinity h of k into e power minus j omega k. So that y of n equal to e power j omega n into h of e power, here h of e power j omega is nothing but the frequency response analysis, frequency response of the system, which is equated to sigma k equal to minus infinity to infinity h of k into e power minus j omega k. So it's a complex valued function. So for our simplicity, for our simplified analysis purpose, we are doing this. We are converting this as polar form. Polar form means in terms of magnitude and phase angle form. So h of e power j omega is equal to mod of h of e power j omega into e power j theta omega. H of j omega mod of h of e power j omega, magnitude of the response, and e power theta omega is the phase angle of the response. Okay, so this magnitude response is a even function, so that mod h of e power j omega is equal to mod h of e power minus j omega, whereas phase angle is odd function, that is theta omega is equal to mod of theta minus omega. Okay, this is about the frequency response of the system, frequency response analysis of discrete time systems. So this unit we discussed about the systems, signals, classification of systems. Okay, types of systems, types of signals, and time response analysis of the discrete time systems, force response, and frequency response analysis of the discrete systems, and have done some problems also related to time response analysis of the discrete time systems, force response. Okay, these are all the problems related to force response, and above one is the problems related to time response analysis of the natural response analysis of the discrete time systems. Okay, etc. So doing the problems we can understand concepts very well. Natural response of zero input response. Okay, time response analysis discrete system like this. Next, properties of jet transforms. Okay, and jet transform, convolution property. All these things were discussed in this unit. Okay, next, system function. What is meant by system function? System function is nothing but the output by input response. Okay, so these all topics were discussed in our first unit. Okay, time shifting property, linearity property. All are aware of all these things in your signals and systems subject only. Okay, right? Mm, these are all the topics involved in the unit 1. Okay, convolution. Next, convolution of the two sequences. Okay, problems of testing stability. So these are all the small problems. Okay, this is about the today's class. Okay, in the next class we'll see the next topics. Like this, I'm concluding the today's class. Thank you.